Notes for interior angles of a polygon. Content objectives is I will be able to classify polygons based on the number of sides as well as apply formulas for calculating both the measures of the interior angles and their sums. We start off by looking at this note sheet with a definition of a polygon. A polygon is a closed figure consisting of segments called sides, which intersect with other sides at their endpoints, forming vertices. So here's a little sketch of a polygon. It's got, these sides should be connecting, but you'll see some better ones down here. They're connecting, and the points where they touch, these corner points, are called vertices or vertex. We have special names for several of them, so in a minute you can pause this video if I go too fast and copy down their names. We start with a triangle. Everybody knows a triangle. A three-sided figure with three angled closed figure, or, three sides. A quadrilateral, quad means four, so that's a four-sided closed figure. And then we go on to pentagon, hexagon, and heptagon, 5, 6, 7 sides. Octagon, 8-sided. Nonagon, 9. Decagon, 10. Hendecagon, 11. Dodecagon, 12. And then anything bigger than that, the general term is called an n-gon, but an n-sided, n-angled closed figure. For instance, if n was 36, if we had 36 sides, we'd call it a 36-gon, or 25 sides, a 25-gon. Okay, so there's the special names. Again, if you need to pause it and copy some of those, go ahead. I'm going to get on to the next set. We'll deal with the terms convex and concave polygons. Here's one definition of a convex polygon: a polygon with interior angles that each measure less than 180 degrees. So each of these angles in here are less than 180 degrees. Concave, a polygon with at least one interior angle that measures more than 180 degrees. So you can see this angle is more than 180 degrees. The way I've seen it described before is, one way I describe it is kind of caved in here. It's dented in here. Another thing is, if you take a segment and go from one endpoint to another endpoint, and it's outside of the interior of this polygon, it's caved in, it's concave. Whereas on a convex polygon, if you go from any endpoint to another vertex, you stay inside the polygon like this. Okay? So there's several ways of figuring out whether it's convex or concave, Concave, it's caved in, or if you go from an endpoint to another one and you're outside of the interior of the figure, that's concave. Okay? You'll be classifying some of those later. Now we come to the important stuff. You have a little block, but you don't have the formula in here. It says the sum of the measures of the interior angles of a convex polygon with n sides is. So sum means all of them adding up. I'll draw a little polygon here. Let's see. Let's take this guy here. The interior angles are these ones inside here. Here's one of them. And here's another one. This one has 5 sides, so it has 5 interior angles. It's a pentagon. And if I add up the measures of all these angles, that's what this formula is for, to tell you how much they should all add up to be. So you take, to figure out how much they all add up to be, it's 180 times n, the number of sides or angles, minus 2. So we'll see some examples of that, but copy the formula down in that block. That's going to find the sum of all of the interior angles. Example 1, we'll do a problem with that. It says find the sum of the interior angles of a decagon. So if you forgot what a decagon is, go look at your first page, because we need to know how many sides it has. And a decagon is a 10-sided figure. So in the formula, n is going to equal 10 because n represents the number of sides. So we look at our formula again. The sum of all these angles equals 180 times n minus 1, or 180 times 10, the number of sides or angles. And you put that into your calculator, you should get 1,440. All of these angles will add up to 1,440 degrees. Okay, later we show you how to figure out one of the angles or a missing angle. Try the quick check. You might pause it now, see if you can do it, and then check your answer. Let's see, what do we got? Find the sum of the interior angles of a 20-gon. 20-gon has 20 sides. So n is 20 in the formula, so we have 180 times 20 minus 2, which is 3,240. Okay, so there's how you find the sum of all the interior angles. Next, example 2. We show a polygon where we're missing one of the angles. Okay, well, the first step is to figure out how much all of these should add up using our sum formula. How much should all the angles add up to be? Well, we've got 1, 2, 3, 4, 5, 6 sides. So in the formula, n equals 6. So the sum of all these is 180 times 6 minus 2, or 720. These should all add up to 720 degrees. So we're only missing one here. So one way to do it is now subtract all the angles that you are given, that you know here, these 5, and what's left will be the one that's left over. So I took 720, the total of all of them, the sum of all of them, minus, I think I started about right here. So minus 90, then minus 130, and minus another 130. I don't know this one, that's what I'm trying to find, so I'll subtract the rest. Minus 120 and minus another 130 will equal x, which is left over here. So that leaves us with 120 degrees after we do all that subtraction. So the x, that angle there, equals 120. Okay. Let's see what's next. So we have a similar example in example 3. It says set up and solve the equation to determine the value of x. Now we can see that there's 2 missing. So now this time I'm going to set up a whole equation instead of just subtracting the ones I know. Okay. So let's see what we got. We got 5 sides. So over here, I'm going to put the sum of all those angles, or the formula for the sum of these 5, how much they should add up to be, and that formula was 180 times the number of sides, 5 minus 2. Now over here, I'm going to start adding up all these angles. Alright, so I'm going to start here at the x angle and work my way around clockwise. So I know that angle, the measure of that one we don't know, but we're calling it x. Then the next one around is 120, plus this one right here with this corner mark, that's a 90-degree angle mark, so plus 90. And then we come to another x, and then the 120. So we're going to start by solving this. I'm going to go ahead and put this side in my calculator, and I come up with 540 degrees. On this other side, we're going to combine the x's. We have 1x plus 1x is 2x's. And then combine the numbers, we get 330. Now we're going to go ahead and solve this for x. So x is over here. I want to get rid of this plus 330 first and get 2x by itself. So I subtract 330. That leaves me with 210 degrees equals 2x. So now I divide by 2 and I get x equals 105. So each of these angles is 105. Here's the quick check. You're going to set it up similarly. If you want to pause the video and see how far you can get by yourself, that would be a good idea. And then if you get stuck, turn on the video again and check your answer. Alright, so the quick check, we got a quadrilateral. So you look it up on your chart if you forgot. Quad means 4. This is a 4-sided figure. We've got 4 angles here. They didn't draw us a picture. And they say the measures are x, 2x, 3x, and 4x. What is the value of x? So again, we start with our formula for the number of sides. We've got 4 sides. So the sum of these, all of those angles should add up to 180 times the quantity 4 minus 2. 4 sides minus 2. And then we add up the angles, the expressions they give us for each angle. We have x plus 2x plus 3x plus 4x. So let's see, we combine all these x's. We have 1x here, plus 2 more makes 3, plus 3 more makes 6, plus 4 more makes 10x. And over here we plug that in our calculator, we get 360 degrees. So now to undo that multiplication, we divide by 10 and we get x equals 36 degrees. You could, they just asked us for x, but we could figure out what the measure of each one of these is. One of them is just x, 36, the other one is 2 times that, which would be 72, and so forth. That is the end. Now we're going to do example 4 before I quit. All right, so let's look at one more example here. This one has the picture again. Several x terms in here for angles, a few numbers, the 120 and the 90. So we are going to solve for x again. We have 1, 2, 3, 4, 5, 6, 7 sides. Again, if you want to pause this and try and do it on your own and then check your answer, that's a good idea. But here I go. Let's see. So we got 7 sides, so the sum of all those angles should add up to 180 times 7 minus 2. And what do we got? If we add up all these angles here, put it in our equation, I started with the 120, probably going around clockwise, then a 4x, another 4x, another 4x, and then the 6x minus 15. And then the 90-degree angle here, don't forget that one. And then another 6x minus 15. So we're going to combine all these x terms. So first I'll do this side. 180 times 7 minus 2 is 900 degrees. So they're going to all add up to 900. Now the 4x and 4x, that's 8, plus 4 more is 12, plus 6 more is 18, plus 6 more x's is 24x. Then the plain old numbers, I got 120 minus 90 is 105, plus 90 is 195, minus 15 is 180. Okay, so you're combining all these numbers. You can just take your calculator, 120 minus 15 plus 90 minus 15, and you should get 180. So we're solving for x over here. We'll get rid of this addition first by subtracting the 180. That leaves us 720 equals 24x. And then undo this multiplication with division, divide by 24. We get x by itself, and it equals 30 degrees. Alright, so that's the end of part 1. We'll start part 2 in a minute. You can go to the website and start part 2.